Atkins Civil 3D video series, Water 3B, Profiles, Vertical Deflections and Bends. This video illustrates A. Check for pipe crossing conflicts, B. Water pipe joint deflections in profile, C. Water pipe vertical bends in profile, and D. Pipe bends with horizontal and vertical angles. Each water pipe crossing with a storm or sewer pipe needs to be analyzed for a possible conflict and what measures should be taken to resolve such conflict. Water pipe can easily be deflected around other pipe, but it is difficult to deflect storm or sewer pipe. In any water pipe vertical deflection, the pipe slope to prevent crests should be kept in mind. There is a conflict with the storm pipe crossing around station 15 plus 60 in Kincaid. The water pipe could be deflected below the storm pipe. The storm pipe could be lowered, which would possibly require the lowering of the sewer pipe. The normal 30-inch minimum depth of cover for a water line is not an absolute. At times, in order to clear obstructions, the depth of cover may be less than 30 inches. However, to prevent water from freezing in the pipe, the top of the water line should be below the frost line. At the 15 plus 60 location, move the pipe joint until it is above the storm pipe. In profile, pick the water pipe and move it to above the storm pipe. Escape. The water pipe will have a depth of cover of slightly less than 2 feet, which is below the 18-inch frost line depth. There is a potential conflict where the water pipe crosses the 96 by 48 RC box around 26 plus 50 in Kincaid. The water pipe is currently slightly above the RC box, which is okay, and has a slope of 0.36%. The pipe cannot be raised without creating a potential crest or high spot in the water line at 47th. There are constraints in the water line at 47th which prevents it from being raised very much. For the purposes of this video, the water pipe will be deflected below the RC box. Draw a 1 foot vertical line below the RC box. L enter to start the line command. Pick the midpoint of the bottom of the box. Move the cursor vertically. Enter 4. Make a copy of the 5-degree vertical joint deflection template below the RC box. CO enter to start the copy command. Pick the template. Enter. Base point. Pick the midpoint of the horizontal line. Insert point. Pick the bottom of the vertical line. Escape. Analyze the template and pipe profile east of the RC box crossing. 4 pipe joints are required, 1, 2, 3, and 4. And the pipe slope of this section of pipe can be increased. Analyze the template and pipe profile west of the RC box crossing. The profile of the water pipe between 24 plus 00 and the RC box needs to be modified to eliminate crests or high spots in the section of pipe, and 3 pipe joints are required. 1, 2, 3. Insert pipe breaks for each vertical pipe joint angle point. Pick the pipe and profile. In the context-sensitive pressure networks ribbon, edit network. Profile layout tools, break pipe. Except for large diameter pipes greater than 24 inch, the pipe joints do not have to be at an exact location. Only a visual representation is required. Visually hover over the pipe and profile vertically in line with the template angle point until the break glyph appears and pick. For some unknown reason, a section of pipe on one side of the break is deleted in profile view. The section of pipe, however, remains in the plan view and can easily be redrawn in profile. Escape, pick the break pipe icon again. Pick another angle point location. Repeat until all desired pipe breaks have been created in profile. When finished, escape. Pick the pipes in plan view. In the context-sensitive ribbon, draw parts in profile. Pick the profile view. Pick each pipe section in profile. Pick the center glyph at a pipe break, and with snap-on, move vertically to the angle point in the template and pick. Repeat for other sections of pipe. Escape. During the installation of the pipe needs to be inserted in line with the previous pipe. The pipe is deflected after the joint is made. The pipe deflection offset distance for a 20-foot section of pipe is 20 times the sine of 5 degrees, which is 1.74 feet. It is generally left up to the contractor on how he wishes to perform the work for the installation of the pipe. He may wish to install bends in lieu of deflecting vertical pipe joints. It is the decision of the engineer to determine the least cost method. The engineer may allow the contractor to install the pipe at the more expensive method, with payment therefore being made at the lesser cost method or at a negotiated price. At times, the pipe may be shown in the wrong profile view. In such cases, pick the pipe in plan view. Make a note of the pipe name as shown in Properties palette: 888, 891, 894, 828. Pipes 888 to 894 should not be shown in Ken Crown Right profile view. In Prospector, Alignments, Centerline Alignments, Ken Crown, Profile Views, right-click Ken Crown Right, Properties, scroll down to See Water, 888 to 894. Do not draw these pipes in profile. Remove the check mark from Yes. Apply. OK. The pipe profile is now shown in only one profile view. After the pipe has been deflected below the RC box, there are some issues with the profile of the water line to the west that need to be resolved. There is currently a sag in the water line around 24+30, which creates a crest or high spot around 25+60. The joint deflection around 26+05 exceeds the maximum allowed 5-degree deflection. Draw a temporary 0.5% grade line from the top of the pipe at the sag around 24+30 that extends to the east. Enter. With snap off, visually pick the top of the pipe at the sag. Move the cursor to the right and enter at 200, -4. Enter. Escape. Pick the line and use Properties palette to change the color of the line to a yellow so that it can easily be seen. Escape. Pick the pipe and use the top glyph at the pipe joints and move down to the yellow line. Visually use the joint deflection template to move the pipe break around 26+05 to where the pipe joints do not exceed the 5-degree deflection. Escape. The water line in 46 South needs to be installed below the 84x48 RC box. In order to show the profile of the water line on the north side of the center line of Kincaid, a 50-foot miscellaneous alignment and Water 46 South profile view have been created. A copy of the vertical bend template is shown in profile with the bottom horizontal line being 1 foot below the bottom of the RC box. In order for the pipe to be within available right-of-way, the horizontal bend at 9+74 needs to remain at the horizontal alignment location shown. Pick the bend in the profile, pick the center glyph, and move vertically to intersect the horizontal template line. Escape. Enter to start the move command. Pick the bend template, pick the angle point, and move horizontally to the center of the bend. Escape. Insert two 22.5 degree pipe bends in 46 south, one south of the Kincaid center line and the other north. Pick the water pipe and plan. In the context sensitive ribbon, edit pipe network, plan layout tools, pipe 6-inch, fittings, elbow 6-inch 22.5 degree, pertinence 6-inch gate valve, add fitting. Hover over the pipe south of the center line until the connect glyph appears and pick. Hover over the pipe north of the center line until the connect glyph appears and pick. Move the labels. Escape. Connect the other pipe to the bend. North and south of the center line. Escape. Pick the pipes and bends in plan view south of the center line. Draw parts in profile. Select the 46 south right profile view. Escape. Pick the pipes, bend and tees north of the center line in plan view. Draw parts in profile. Pick the water 46 south profile view. Escape. Escape. Pick the bend south of the center line. Pick the center glyph and move vertically to the intersection with the bottom horizontal line of the bend template. Escape. Pick the bend in plan view. Pick the center glyph with snap off. Move along the alignment of the pipe. Repeat until the center of the bend in profile is at the angle point. Escape. Draw a 1% grade line from the T. Enter to start the line command. Visually pick the center of the T. Move the cursor to the left at -100, -4. Enter. Escape. In profile, move the bend north of the center line to intersect with the 1% grade line. Pick the bend, pick the center glyph, and pick the 1% grade line. Pick the other pipe, pick the center glyph, and connect to the bend. Escape. In plan view, pick the bend north of the center line, pick the center glyph, and move along the alignment of the pipe and pick. Connect the pipe as needed. Repeat until the center of the bend intersects the 22.5 degree slope line in the profile. Escape. At times, a bend is used for both a horizontal and a vertical deflection. Such is the case for the two bends at 9+74.2 and 9+63.4 in 46 south. As shown in plan, the horizontal offset distance is 28.2 minus 23.9, which is 4.3 feet. As shown in profile, the vertical offset height is 446.2 minus 438.8, which is 7.4 feet. The trigonometric equations associated with the compound horizontal and vertical deflections of pipe bends are shown. An Excel spreadsheet is shown of the computation for the two 22.5 degree bends having an offset distance O of 4.3 feet and the height distance H of 7.4 feet. The computed station distance S is 20.7 feet and the computed length L is 22.4 feet, which is the length between the centerline PIs of the two bends. The distance between the centerline PI and the pipe insert point for a 6-inch bend is approximately 0.4 feet or 0.8 feet for the two bends. The required length of pipe between the two bends would be 22.4 minus 0.8 or around 21.6 feet, which is a greater distance than a standard length of pipe. Using a pipe length of 19.5 feet, which is a standard length with a bell end cut off, the distance between centerline PIs of the two bends would be 21.3 feet. The spreadsheet currently shows the computation for the two 22.5 degree bends having a length L of 21.3 feet and an offset distance O of 4.3 feet. The computed height distance H is 6.9 feet and the station distance S is 19.7 feet. The drawing currently shows the two 22.5 degree bends in plan and profile having a station distance of 19.7 feet, an offset distance of 4.3 feet, and a height distance of 6.9 feet. The joints at the bends and along the pipe to the south are deflected as needed with a maximum deflection of 5 degrees at any one joint. The pipe note for the section of pipe between the two 22.5 degree bends indicates a pipe length of 19.5 feet, which is the actual length of pipe required to provide a length of 21.3 feet between the centerline PIs of the two bends. An alternate method would be to install two 45 degree bends in lieu of the 22.5 degree bends. This would probably be the method the contractor would choose during installation. The spreadsheet currently shows a computation for two 45 degree bends having an offset distance O of 4.3 feet and a height distance H of 7.4 feet. The computed station distance S is 8.6 feet and the length L is 12.1 feet, which would require 11.3 feet of pipe between the two bends. This video is a part of the Civil 3D video series created by Gerald Atkins of Atkins Engineering. Visit www.atkengr.com for instruction manuals, tutorial drawings, template drawings, and Civil 3D videos.